Good morning, dear students. Today we are going to discussion about the next concept, Gauss law or Gauss theorem. See, to understanding this Gauss law or Gauss theorem, we must able to know that electric flux concept. See, that electric flux already we have been studied in the previous class. It's the most important concept about this electric flux. What actually mean by that electric flux? How to visualize this electric flux concept? See that any one surface, in this surface what happens now? Number of electric field lines passing perpendicular to this surface. Passing perpendicular to this surface, that is nothing but electric flux. As already we studied what actually mean by that electric flux concept and all the things. See, that Gauss theorem, that Gauss law, how to visualize this particular consideration, that Gauss law or that Gauss theorem explained, and also it gives that relationship between, that's what, the relationship between, say, electric flux as well as, say, that net electric charge concept, charges enclosed in the closed surface. See, first of all, as usual, we must able to know that about this electric flux. This is that one surface area. So for this surface area, what happens? There is that area. That's the area vector. You must know that this is the area vector A. And through which what happens now? There is some that electric field. That's electric field intensity, that E. It makes an angle theta here. It makes an angle theta, that is what we call it now. Say that electric flux. What happens? This is very small area, we call it now. That small area through which there must be that number of electric lines of force passing normally through the surface area, so that there is some flux will be produced. That flux, a very small flux will be produced through this small area, surface area. That small flux, how much it is? D pi. D pi equal to what? Say that E into, say that's A cos theta. A cos theta. Or you may able to take that's dA, you may call it no. So yes, it is a dA cos theta. Because it's a small area, we call it no. Instead of taking the dA, we may able to take it as the ds also. Nothing wrong at all. So far, the d pi equal to E into ds cos theta. See, in some books they have been mentioned. Say the dA also, that is a surface area. ds, that is also the surface area. For your convenience, to understanding, can able to use that area A or small area dA or small area ds. That is left to you only. That you can able to analyze here. Yes, that I will take, say, E into ds cos theta. So if suppose the theta equal to 0 degree, what happens now here? Theta equal to 0, d pi equal to E into ds. So far, this is the flux will be produced. Say that Gauss law, that Gauss theorem explained that relationship between, so what now? The electric flux as well as the charges enclosed in that closed surface. That is what he explained. So you must know that what actually mean by the flux, how to visualize that, all the things. Number of electric lines of force are passing normally through the surface area. That is nothing but the flux now. So far here, that Gauss law, how to say define, that's the statement of this Gauss law. So for this Gauss law, let me take, it is a very simple concept, the statement, how to define this. The statement, we must know that statement of this Gauss law. State and explain this Gauss theorem, or say state and explain this Gauss law. That's a question sometimes they may able to ask. You can able to use this applications of this Gauss law. Using this Gauss law, we are going to derive some more that electric field concept also. So for in this particular consideration, how we can able to say that Gauss law states that total electric flux in a closed surface is equal to 1 divided by f naught times of total charges and closed in that closed surface area. Closed surface. This is what now? According to this Gauss law, total electric flux, simple one, total electric flux in a closed surface, is equal to 1 divided by f naught times is equal to 1 divided by f naught times equal to 1 divided by f naught times total charges enclosed in a closed surface. So far, this is the statement of this Gauss theorem or Gauss law. In these particular considerations, I would like to find out total electric flux, that is pi E, closed surface, 1 divided by f naught times total charges enclosed in this closed surface. See, it means what? Let me know. Pi E equal to 1 divided by f naught times of total charges enclosed in this closed surface. This is what I said, that electric flux now. I mean, Gauss law. To understanding this Gauss law, we must have the basic idea about the electric flux. As already I told, the electric flux, suppose the d pi equal to E into ds, you may call it electric flux. Say this electric flux, total electric flux, that what we supposed to know. This total electric flux equal to surface integral of E into ds also. Surface integral of E into ds, that is nothing but the electric flux concept. But in this case, the flux in that electric flux, that's pi E. As usual, that already we have been studied about the concept of electric flux. So that in this case, what happens? Say pi E equal to 1 divided by f naught times of total charges enclosed the Q. But we know the total electric flux through that particular surface. Say surface integral of E into ds. This is also the flux. This is also the flux. That Gauss law, how exactly it is? In this case, surface integral of E into ds. Surface integral of that E into ds. In this case, what happens? That E, that's the electric field, that's E. Say that E is nothing but what now? That electric field, say over the closed surface, electric field over the closed surface, enclosing the charges. That is what we supposed to analysis in this case. This is the electric field. Say the ds is what now? The surface area. So this is the surface integral. That is what we must able to analyze how exactly the basic concept about this electric flux, electric flux as well as say electric field, how they must be related to each other, and also in this case electric flux, and also say the charges enclosed in that closed surface area. This is a basic phenomenon and most important concept that I would like to analyze here. See how to visualize this particular concept. I want to derive the proof of this Gauss theorem. Already we know that pi E equal to 1 divided by f naught times of that Q. I want to derive this. I want to get that one. How it is. Let me take how to analyze this one. Let me take particularly about this Gauss theorem. Say this is the statement, total electric flux in a closed surface is equal to 1 divided by f naught times of total charges enclosed in that closed surface. Let me take, this is the charge. So the charge, so charges enclosed in this closed surface. Okay, it's a radius. let me take this is the sphere. So far, this is sphere of a radius, we may call it now, that is R. Say here the small area, here the small area, that the small area, that is the ds, we call it now, the small area. Say for this is the ds, we call it now, small area ds. So far, if suppose that electric field is along this ds, that is the E. So here there is some electric flux will be produced. That electric flux is d pi. D pi is the electric flux will produced on this surface area. The surface area, that is the ds, electric field, it is along this ds only. So for this surface area, it is almost normal to this surface area. So we know that there must be some flux will produce. That flux is how much it is? That flux d pi equal to E into ds. Correct? E into ds, that is the flux produced here. So far, one more surface area you may able to take like this. Correct? Yes, its radius is R, and this is the surface area ds. Electric field is that E along this area, in which what happens, theta equal to 0 degree. Yes, that I told. Here also the theta equal to 0. E into ds, cos theta equal to what? Theta equal to 0, E into ds itself only. So for again, there must be flux will produces, that flux equal to E into ds. Because in this case, we have that relation E equal to E into ds cos theta, that is the flux will produce d pi. So theta equal to 0, E into ds it is. The d pi equal to E into ds. That already we have been studied about the electric flux concept. So the same thing that we must be able to apply here also. Say that d pi equal to E into ds here also. But this is sphere, that's what? Charge is enclosed on this closed surface. It is entire this closed surface. There is a sphere on this surface. There must be some small areas. To make this entire surface, that sphere, there is a small surface area. There is a small surface area. That small surface area, so far the area is the ds. So far there must be that flux will also produces. No? There must be some flux will also produces in this case. But I want to find out that entire, so that entire the flux through this entire this surface sphere, entire this surface. What you should be able to get it now in this particular consideration? Total electric flux equal to that should be equal to, say, integration of E into ds. Integration of E into ds, surface integration. As usual, we must able to know that basic concept here, what actually this particular values mean. See, pi, that is a total electric flux concept here. That should be equal to, say, integration of E into ds. It means that already I told in the previous class, integration is the additive property. It should be increases. So it's a very small surface area, very small electric flux will produces for this area. But I want to find out the entire this surface. Now ಹೇಳ್ತೀವಿ small surface area ಇದ್ದಾಗ d pi ಅಂತ ಹೇಳ್ತೀವಿ, that's the electric flux. But ಇಲ್ಲಿ ಏನಿತ್ತು ಅಂತಂದ್ರೆ entire this closed surface area ಅದ ನಮಗೆ electric flux ಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಇವನು ಎಲ್ಲವೂ ಕೂಡ ನಾವು ಏನ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು, ಕೂಡಿಸ್ತಾ ಹೋಗ್ಬೇಕು. ಇದು ಒಂದು ಸರ್ಫೇಸ್ ಇದೆ, ಇಲ್ಲಿ ಒಂದು ಸರ್ಫೇಸ್ ಇದೆ, ಇದು ಒಂದು ಸ್ಮಾಲ್ ಸರ್ಫೇಸ್ ಇದೆ. ಈ ರೀತಿ ಎಲ್ಲಾ ಸ್ಮಾಲ್ ಸರ್ಫೇಸ್ ಏರಿಯಾನ ನಾವು ಆಡ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಇಂಟಿಗ್ರೇಷನ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ಅ ಅಡಿಟಿವ್ ಪ್ರಾಪರ್ಟಿ. ಅದಕ್ಕೆ ನಾವು ಹೇಳ್ತೀವಿ ಎಂಟೈರ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಸರ್ಫೇಸ್ ಇಂಟಿಗ್ರಲ್ E into ds ಅಂತ ಆಯ್ತು. ಲೆಟ್ ಮಿ ಟೇಕ್ ಇನ್ ದಿಸ್ ಕೇಸ್ E, that should be the constant, say E into ds. See, you must know that surface integral of ds. ನಮಗೆ ಇದು ಸ್ಮಾಲ್ ಏರಿಯಾ. ಈಗ ಏನ್ ಮಾಡಬೇಕು, ಎಲ್ಲವೂ ಕೂಡ ಸ್ಮಾಲ್ ಸರ್ಫೇಸ್ ಏರಿಯಾನ ಆಡ್ ಮಾಡಬೇಕಂತಂದ್ರೆ ultimately the total area will get it. The total area of this sphere, let me take here E into A, total area. This total area of this sphere, area of the sphere is what now? Of course that A or simply the ds equal to 4 pi r square. That is the area of this sphere. Then I can able to write E into area of the sphere is 4 pi r square now. So for total electric flux, pi equal to E into 4 pi r square. But in this case, I would like to find out electric flux through the surface area. Then already we have got this pi equal to E into 4 pi r square. But we have that very important consideration, very important point in this case. About this distance is r. I want to find out the electric intensity at a point due to this point charge q. We have that relation that E equal to 1 divided by 4 pi epsilon naught q divided by r square. Because of this particular that relation that E equal to 1 divided by 4 pi epsilon naught q divided by r square. Then this relation pi equal to 1 divided by 4 pi epsilon naught q by r square into 4 pi r square it is. 4 pi get cancel, r square get cancel, it is q divided by epsilon naught. Pi equal to q divided by epsilon naught, this is the expression for Gauss law, that Gauss theorem. So as usual in this case, this is what exactly that pi equal to q divided by epsilon naught. Just you see that the statement of this Gauss theorem. Already we know that total electric flux in a closed surface is equal to 1 divided by epsilon naught times of total charges enclosed in this closed surface. Let me know that pi equal to q divided by epsilon naught. As already we know that this is the expression for that Gauss theorem or that Gauss law. The physical significance of this Gauss law, that is also very important concept. As already we know that Gauss law, it is true for any closed surface area. It is closed surface area. It should be, say Gauss law must be true for closed surface area. Closed surface area. Surface area. It should be true for that particular concept. And Gauss law, there is no matter about size as well as shape. There is no matter about the size as well as shape of that particular body. See, there is no matter about size and shape of that body. Let me take particularly how the size. So far, in this case, what we supposed to know? This distance, that's radius, that is 2r if you may able to take. Say if it is 2r, then what happens? Say that pi equal to 1 divided by 4 pi epsilon naught, say q divided by 2r whole square, and that area of this sphere 4 pi to r square. So far, these two get cancelled, 4 pi get cancelled, again we may able to get it now q divided by epsilon naught. Its a size, it will change because its radius is r initially. If the radius will be that r initially, then what happens now? Then it will change the r to 2r. Again, the total electric flux remains q divided by radius naught. That is the special about this Gauss theorem. So far, the Gauss law must be applicable for that extended charged conductors. That any shape of the conductor, you may able to use this Gauss law. So for this Gauss law again, then what happens now? There must be change in their size. The radius will change. What happens now? Pi equal to q divided by the epsilon naught. This is what I said. You may able to take the 2r, you may able to take x or d, whatever it is. But ultimately, if it is not able to change, pi equal to say q divided by epsilon naught. See, in the same way, what happens now? About this Gauss law, say pi equal to 1 divided by epsilon naught times of total charge enclosed in this closed surface area. That is what we have been studying. Similarly, what happens now? Charges enclosed in that closed surface. What happened? Charges enclosed in a closed surface is nothing but the Gaussian surface. See, for the concept of Gaussian surface. See, Gaussian surface. What actually mean by this Gaussian surface? So for in this case, this is the charge plus Q. So the charges enclosed this closed surface. This charges that surface we call it now the Gaussian surface, or the surface in which the Gauss law must be applicable. That is nothing but the Gaussian surface. So in the same way, ultimately what we came to know that see the size as well as shape, that or no matter about the size as well as shape. Even shape, it may be the cylindrical shape of the conductor, it may be that any shape of the conductor, it may be that plate, anywhere. Ultimately the Gauss theorem or Gauss law is applicable. Again it should be what? Pi equal to Q divided by the depth naught. The Gaussian surface cannot pass through that any discrete charge. That is also one of the important concept. That is the Gaussian surface, the phenomenon. And Gauss law, it is always we can able to analyze this. Say ultimately, so this Gaussian surface or the Gauss law must be applicable that particular surface. That's a Gaussian surface concept. No? That Gauss law is ultimately, Gauss law is very useful when the system has a symmetry. These are all some of the physical significance of this Gauss law. As usual, in this session, that what we have been discussed about the Gauss theorem. It's a statement as well as that explanation. It's a proof how exactly it is. And in the same way, what are the physical significance of this Gauss law that we have been discussed in this session now. So this Gauss law, very first time that I already told, to understanding this Gauss law concept, try to understand the electric flux now. Electric flux means what? How to visualize that one? All the things better you should try to know that. This is very important. Then say, if you know the Gauss law, then you can able to derive some more the derivations for your board examination point of view. See, ಯಾವಾಗಲೂ ನಾವು ಗಾಸ್ ಥಿಯರಮ್ ಅಥವಾ ಗಾಸ್ ಲಾ ನಿಮಗೆ ಗೊತ್ತಾಗಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಗೊತ್ತಾಗಬೇಕಾಗಿತ್ತು ಅಂತ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್ ಅದು ಕೂಡ ಅಷ್ಟೇ ಇಂಪಾರ್ಟೆಂಟ್. ಏರಿಯಾ ವೆಕ್ಟರ್ ಇರ್ಬೋದು, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ಬೋದು. ಎಂಟೈರ್ ಈ ಟಾಪಿಕ್ ಅನ್ನ ನಾವು ಅನಾಲಿಸಿಸ್ ಮಾಡಿದಾಗ ನಾನು ಹೇಳಿದೆ ವೆರಿ ಫಸ್ಟ್ ಟೈಮ್ ಈ ಟಾಪಿಕ್ ಅರ್ಥ ಆಗ್ಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ 3 to 4 ಪಾಯಿಂಟ್ಸ್ ನೀವು ಬಹಳಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡ್ಕೋಬೇಕಾಗತ್ತೆ, ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು, ಅನಾಲಿಸಿಸ್ ಮಾಡ್ಕೋಬೇಕು. ಒಂದು, ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್ ಬಗ್ಗೆ ಹೇಳಿದೆ, ಕುಲಂಬ್ಸ್ ಲಾ ಅಂತ ಹೇಳಿದೆ, ದೆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕಾನ್ಸೆಪ್ಟ್, ದೆನ್ ನೆಕ್ಸ್ಟ್ ಗಾಸ್ ಥಿಯರಮ್. ಈ ಗಾಸ್ ಥಿಯರಮ್ ನೀವು ಪರ್ಫೆಕ್ಟ್ ಮಾಡಿದ್ರೆ, ಗಾಸ್ ಲಾ ನ ಅನಾಲಿಸಿಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ, next their applications are there. Means applications of Gauss law, applications of Gauss theorem, that is also in which there are some more the derivations for universal levels. So 3 to 4 derivations are there, that will discussion in the next class.